Hi, everyone. And today I'm privileged to have Leo and Marius here with me to talk about the symbolic AI architecture. So the last time we talked about how everything can be represented as symbols, and you can perform manipulations on the symbols with operations, expressions, and even LLM-based functions. So today we'll be talking about more in-depth features of the symbolic AI architecture, which is namely using the chatbot, which is able to use tools to answer to user queries. So without further ado, I'll leave it to Marius to demonstrate it to you.
Thank you very much, John. Thank you. Let me first share my screen. So we're now here in the terminal. You should see my screen. I already have the SymbolicAI package installed and already loaded the Conda environment, SymAI. And we also install some useful tools alongside the package, one of them being SymChat, just to play around. SymChat is basically using now, in this case, using ChatGPT in the background. And for instance, we get here, let's say, hello, how can I assist you? Now we can place any question here. And depending on the question, let's say, I don't know, how is the weather? Is the weather in Linz, basically near where I live. Now it's basically analyzing this question, looking it up, and then comes back with, let's say, some using the search engine, in this case, Google in the background, and comes back with this reply. We can obviously also ask it, I don't know, what is, I don't know, solve x squared plus 1 or something like that. Then it kind of triggers in the background the classification, looking at that it's probably for Wolfram Alpha, extracting that information and sending it to Wolfram Alpha to evaluate the result. So that's kind of how it works in its basic functionality. We can also play around, open files, or do other stuff with it. But maybe to show you a bit how this works, I kind of prepared this notebook here, which we can now stepwise go through it. So basically, if I load this notebook, what we see here is now, so let me maybe restart it first, because, yeah. So this is the initial run. What we see here now, this is actually Symbia chat. So if we import everything, Symbia chat is one of the components that we also can import. That's exactly what you just saw in the command line. In this case, we're now initializing the chatbot again from the capabilities. And now we can also ask, I don't know, how the weather is in Rome, for instance, or whatever, suggest me some low carb food or so. And in this case, we're just triggering one step of procedure, whereas we had here below, let's say, a loop, and we were iterating over that loop of capabilities. What actually Symbia in the background also uses is different components. We'll talk about a few components today. One of them being, let's say, the file reader. As you have here, you can, for instance, let's say, initialize a reader. I have something on my desktop. In this case, this is just my resume. If you look, we read in this file, you can look at the type. You see that this is an expression, basically. So it's itself a symbol, and then we have this hierarchy from maybe last time you remember: symbol, then expression, and then all the other expressions that can be derived from. And now we can basically quickly just place a query on top of it. So that's why we have this helpful functionalities on it, like querying. So when we say, let's say, when did Marius work at Celium or so, and this should hopefully evaluate this all of this stuff. And you see that this kind of works out. But what happens in the background is, or what you also can do if you want to make more composite way of executing these simple functions, is using the components. What we have here called query, for instance. And just to give you a bit of an overview, if you look inside the package of SymAI, and if we take a look at, let's say, symbol, you will find here many of these functionalities, one of them being the query, as you saw right now. But also you will find like this components.py here. This components.py basically has also somewhere a query statement or query component built in. And there are several others. You see style above, maybe outline below, and many, many others. In this case, it's basically just forwarding this functionality. So why do we use this way? Because the idea would be that you can now sequentially compose, let's say, more complex streams or a sequence basically of components. If you're familiar with PyTorch, you know that there's a sequence class in there where you can just open up basically a sequence and then just streamline multiple other, what is it, modules, I think, through the sequence.
Yeah,
kind of the
just
same
to add on
thing here.
something here. So
Yes.
for this small letter q and the large letter q is very similar. In fact, it's exactly the same as what PyTorch does. So like PyTorch functional is the small letter q, where you can do the function directly on the symbol itself. While the large letter function, the q, is something like composing a block, which you can then specify terms of section operations. Like you do one block first, then you do the next block, and so on. So that is exactly what this large letter q query does. It actually creates the symbol at the back end and runs the symbol. Maybe you go back to the code there to just show.
So here you see the small letter function. Here you see the component, for instance. So this was the class, the component that we opened. And you see that we're basically getting a symbol. We're also checking if it's a symbol, otherwise we upcast it. This is important if we compose multiple components together and some of them returns maybe a string or something else. And then we see here that we have sym.query. So we are basically just querying this, we call this function, which is in the symbol class defined. And you see that this is just pipelining it back to the backend, where we have some context, some prompt, and so on. So this is, we can talk another time about all the details, how this is going, but basically this is now sending it as, wrapping it as a few shot prompt, saying it as functional in the background, executing that functional on the LLM, and then coming back and then, basically evaluating here. So we're just defining the function here locally, and then we're just executing it. And then we're packaging everything again as a symbol to always ensure that we have this fluent API that we can just say .query, whatever. So this is kind of like the main concept of also the framework. Yeah, that's what you see with these two components, or with this component and this function.
Yeah, that's cool. Just before we move on, just want to highlight. So we use the small letter q for the query when you already have a symbol. Like maybe you scrub. So you have a symbol and you want to perform operations on it. That is directly performing it like an operation. And you do the large letter one if you want to define a process. And that's when you don't have a symbol defined, then you can define a stream of process. And that whole stream of process is something like a function, which you can then call later and execute the whole stream. So that's something very cool because you can operate with SymbolicAI at two different approaches. All right, yeah, I guess we can move on now.
So, I mean, you said it exactly. So when we have, let's say we have more elaborate documents, a bit larger. Let's say this is a paper, I think, in the background, and we want to stream now over an entire paper or over entire, much larger context. If you just use this query as is saw above, that will basically just query very atomic, because our philosophy is first make it very atomic, and then you have this compositionality where you can just streamline multiple functionalities on top. So let's imagine we're exceeding the context size of the model of, let's say, ChatGPT or whatever we're using. For that use case, then we have to think about smarter ways how to process that information. And what we came up with is this component called indexer, where the indexer, if we look it up, in this expression, basically uses it. So sorry, where is it here? It basically, what it does is it goes over the document and kind of like chunks it apart, and then just in each chunk gets indexed. So what you're doing is kind of you're embedding you're kind of embedding basically each chunk and inserting it into a database, and then you're kind of just initializing it initially, and then you can perform the query on top of that. So let me just demonstrate that before we go into any details or so. Yeah. So basically what we get back should be, again, an expression. Exactly. You see that this thing is a bit large. And if we now, for instance, go over, let's say, the indexer here, now we're kind of indexing the entire text. So we have basically initialized the object here at the top.
Maybe it's important to say that the length of the text, if it's a symbol, is a number of tokens, if that's the case there, right?
Oh, yeah, thank you very much. That's a good point.
Yeah.
Because since we're working on symbols here, or expressions in this case, we care about, since we will intend to send this to a large language model in the background, when we call length on this object here, it's basically already converting it to a token, estimating or giving basically the number of tokens. If you want to really know the length of the text, then there is always, maybe you also remember from last time, there's always a value in each expression and so on, where you can say text.value, and it basically unwraps the original string. And then you see this is actually the length of the string of the actual text. So good point, thank you. So apparently it already indexed basically the stuff here. And we can now start placing queries on top of this document. I don't know what was the document about.
Maybe you ask it to summarize the document. What is the document? I don't know.
So can I open this PDF somehow in Visual Studio Code? Is that possible? Works. So this is industrial society and its future, basically, a document about, maybe you can talk about it, Leo, because you kind of pulled it up.
It's probably not the most illustrative document. This is Ted Kaczynski, which was the Unabomber, but I just wanna search basically in this document. I had it on my desktop as a PDF, and I just wanted to see what was his thoughts on technology, and I just streamed that over the entire document to see how he viewed technology, for example, or how he viewed I don't know, the industrial revolution or something like this. That was the point. It's just an example.
Yeah. Now what you can do is basically with the indexer you said before to summarize it. So the indexer is more thought about you're indexing an entire file, and now you're trying to query that file, right? If you want to summarize it, we will show it in a next step. So what we can do now is basically we already got the answer. So technology is a powerful society. Yeah, see, this is kind of like what is it about, right, in this document right now?
Yeah, so this one is a direct extraction of a section of the text that was embedded earlier, and based on some cosine similarity, I believe this is using OpenAI embeddings. Basically the top result will be shown here. I mean, you can also show the top 8 results, which will be helpful later if you want to use this to do this thing called retrieval augmented generation. You can do stuff like document question answer. You can do stuff like retrieve stuff from a web page or PDF document to answer users' queries, talk to a book, those kind of stuff. You can do it very simply using this index function.
Exactly. And there's actually, even if you just want to do it in one step, so you don't want to it's basically, that's what we like about this compositionality of this framework, because you can easily just, have a component written like this, the indexer, but you also need like a file reader and so on. So why not just combine both together, use a document reader? So we thought about like putting this more specialized components into like an extended sub package. And then you can just say, document retriever, where you just directly throw in the string of the document, and then you can just, place the question on top of that. So that's just more, it's the same thing, just wrapped around. But maybe if you care about, as you said before, you want to compose now multiple, let's say, or a sequence of components, or maybe you want to summarize, as you said, right, before. So let's go that way. So let's go again with the reader that we saw before, where we just read in this same file here, for instance. I'm just shortening it down a bit because the text you saw is like really, really long. And we don't want to wait for that too long, because we want to go over all the thing in the, maybe make it a bit longer. We want to go over with the LLM now, basically. Think of it like the LLM is now convolving, quote unquote, convolving over the chunks of the document. So we're not indexing a priori and using cosine similarity to retrieve the information. Now we're just basically shifting over with the LLM over these different chunks. And we should be somewhere in the realm of maybe, I think I'm using ChatGPT with the 16,000 tokens. Maybe I should go a bit larger, because otherwise this is not, yeah.
So just to clarify for people who are wondering, the text.value is the string of the entire text in the PDF.
Yeah.
And by going from 0 to 50,000 is the first 50,000 characters of that string, which
no. Yeah, exactly. Yeah.
Yeah. Then the length of the short text, is it the length of the words that you are referring to here? Because it's
this is not the length of the, again, the tokens. So if we look at the short text, since this is wrapped as a symbol again, as you see it here, this will always give the length of like how many tokens are in here. If we again want to see the length of the value, what's in the short text, then we can just go this way, and then we see that this is the 50,000. That we can
meaning basically 50,000 ASCII characters, like
yeah, exactly. So these are tokens, these are the characters. We always basically transport the length we use, how we would use it on the backend, basically. But if you want to always look at the values, length, and so on, you just say dot value, and then you get that.
So that's
maybe just put 100,000, because with 100,000 you will exceed the context for sure.
Maybe.
Yeah.
I wanted to ask, this token is exactly how OpenAI would view a token in GPT, right? For this length.
It should be. There are some tokens off for that we compensate in the framework, because I believe that they might have some reserved tokens or use, I don't know, some tokens for the system, user, and so on in instructions. That's my, I don't know, they didn't disclose that or didn't say that, but if you compute it with the tick token thing and use the encoder and so on, you're kind of like 13, 14 tokens off or something like that. So we compensate for that. But yeah, it's almost the same.
It's basically their encoder, the encoder that they suggest to use with
Yes.
With a model.
Basically, when you have a string going into symbol, you run this string through tick token, and then the number of tokens that come out from tick token will be stored.
That's the length
in the value, right, of the symbol. Actually, that's very cool because like right now, I'm doing a project whereby I'm trying to split like a document by symbols, by tokens, and this actually can do it like natively because of like how you store it at the symbol level. You store the number of tokens already, so you can split by token chunks as well quite easily.
Yeah, exactly. Yeah, and what we're doing now and what we want to show a bit is two functionalities. So if we do it the usual way, let's say we ignore for a second what's written here, we just would do it this way, we would like easily exceed now the token size. If we just create this function, query, whatever, and then we just put this on the text, the text should be too large, and yeah, exactly. It's basically killing our request. But what we built for that is this stream component. The stream component has now a few functionalities. First of all, I want to show you some equality of the stream component. So how does the stream component actually can be composed? It's basically, if you just transcribe what's written at the bottom there, we could have this like query and have the same question as before. So what we're doing is we're just wrapping around a stream around this query thing. And now basically what we're doing is chunking the text apart. And now we're streaming over with the query component over individual chunks. When you evaluate that as a result, for instance, you would say that because you have to you're getting an iterator back, so you have to say stream of and then short text or whatever. So basically what you're now forcing is by saying list around it, like evaluate my iterator, otherwise you would have to say for each or so. So now you're forcing just the evaluation of the stream component, and now basically this would just compute chunk-wise this over the stream.
So this
you
stream
see,
is an automatic chunker that chunks
exactly.
according to a certain attribute, and like in the function block below, it chunks according to the longest chunk, like the longest possible stream.
Exactly, exactly.
Yeah, so this means that you can split any chunk of text automatically to like maybe the max token for GPT just by using the stream wrapper or this stream function wrapper.
Yeah, exactly. Thank you. But imagine you would have, I like this writing, but what I also like more a bit is this with statements. So what we did here is basically the same class that you see here, just with call trace implemented. So what you can just do now is basically just create a stream above, let's say, the statement here, this query. And if there is a query, a sequence, or a function or so, there are some classes that are supported. It basically auto maps, knows exactly what you defined in here, and then basically does the streaming for you. So you can just use your previous code, just write this one statement above it. You don't have to like convolve it and rewrite your code this way and make it component wise and so on. You could just strap on top of it like this with statement. And if it's one of the supported classes or components in there, then you basically are automatically just doing that. And what we also do here is there's one more thing. I told you this is a list, what comes out, and we will see in a second. But actually, maybe you don't want the list. Maybe you have some strategy how you want to extract that information. Let's say you want to say, because you're now going over chunks and doing this operation. So maybe in all of them, it says like something, I don't know, this information is not in the text. I don't know, this information is not in the text. But in the one part where the information is in the text, it just starts, talking about this entire information. So you could just say, you know what, just retrieve me the longest chunk. So you could implement, and we will also implement further on, different strategies. You can have just all, basically returning all again, so you get the list again. But you can retrieve, different type, based on different type of strategies, how you get back the last result. And what you see maybe also here around it, there's another statement, it's called trace, another component called trace. And in this case, I want you just to trace the engine. One of the engine is the neurosymbolic engine. So I want to just see what this thing does in real time, because otherwise we're sitting here ducks and waiting, and we don't know if this thing is computing or not. So what we can do is now just start this expression, or this stream of expressions. And what we see here is basically with logging, live logging, or what the summarize is kind of doing. So you see that in the first part, it says like the text argues that modern society is disrupted, the power process, and so on. Then it says does not specifically mention the word technology and so on. So you see that these are like how I predicted to you before, that is probably shorter. And then there's one part at the other, maybe the beginning or the end, that is a bit longer. And if you just directly print out the result, we get basically back the text argues that modern society has disrupted. So this is probably the first one. It kind of, yeah, I think it's the first one. So that was the assumption, was in this case correct. That's probably the part with which has the longest text in it is probably the one that contains the information, the chunk that has the longest text after the evaluation contains the information. But what you also can do, like I said before, you could now, yeah, sure.
Or we can have like a top K. You just retrieve the top K
exactly.
results.
It's currently not implemented, but in the next version we also do have top K and whatever. You can imagine now many things, right? How you can do strategies. You can even implement. You just look at the class if you're interested in how this is implemented. It's not so complicated. So it's basically this makes it that it works with the with statements, and here in the forward function you see that basically I'm just looking at if the trace is active, then I'm doing some magic how to get the code back, and these are the supported functions or components.
Retrieval.
Sorry, exactly. Yeah. Function, sequence, query, and then you see that here are the strategies. They're very simplistic. It's the first one is basically just the all that you saw. The longest one you just saw as a result, and the contains. I hope this is also working, but they should basically look if this information is contained in the retrieved text. So basically,
and this is that's not evaluated with the neurosymbolic engine, right? Because you can also do that.
The last one is also, because the last one is also, this is a symbol or a list of symbols, and
okay.
But anyhow,
so it's basically using the large language models to check if it contains the information, right?
Yeah, exactly. So what you now saw is basically a way of how to build up components, how to or compose them together and so on, and then use several functionalities how to process information. And now, since we kind of saw this with behavioral stuff and so on, we can maybe now dare to look into the Symbia, which looks a bit scary at the beginning, but it's actually now just mainstreaming all these functionalities / components that you just saw before. So basically, Symbia chat is just itself a chatbot. As a chatbot, if you look up here, we see that the chatbot is actually an expression. So everything is anyways an expression. Has some components, has some sliding window memory in it, has some vector database memory in it. So basically, you can interact with the bot, and then you can store some information in it, and later on start a new session, and then just query it back again. And there are some other functionalities that I don't want to go into details now. But basically, if you would do your own chatbot, or I think others call it maybe agents, but it's more accurate with this. So basically, this chatbot is using different tools. And what you can do is just inherit from chatbot, override the forward function, and then basically go from here with your custom implementation. So what's happening here is basically there are two ways of this. How is it called? If you call it from a notebook and pass on already an argument from the user, then we don't do any looping. We basically just do one process and then return to the user. If you call it from the command line, as you saw it at the beginning, then you kind of have this loop iterating until the user says exit or stop or so on. And the idea here is we're just look at this user keyword, forget the rest, this one. So basically what we're doing with this user input is we're just detecting what is it about. So we're saying detect capability. So this is just another component that you just saw before. We're just calling one. It's kind of does in context classification based on some predefined functionalities.
If I might add, this part on detect capability is something like choosing the right tool to use to solve the user query. Yeah, so
exactly.
Like
That's perfect.
Of what tool I should use, and if it has classified that a tool use is required, then it will go ahead and use the tool.
Exactly. So you saw this in context classification component here. This one is called. It gets passed in a prompt because we have some prompt templates here in prompts. So it kind of, if you look at the prompt template, you can see that what is happening here. So it kind of has this experience that some toolboxes and so on, some tools that it can use. So you can basically have, maybe if you want to go over this, Leo, a bit because you implemented it. But yeah.
Yeah, so the idea was to split between experience, toolbox, some instructions, and obviously examples, because we're doing few shots learning in this case. So the experience, think about it as using the internal knowledge of the model itself. So the model was trained with a lot of knowledge. It has a lot of information within. You might want to default to that in some cases. And the example that I like to give to show the difference between the experience and the toolbox is again the quadratic example. If you look it down a little bit in the examples, it should be there. Yeah. How do I solve a quadratic equation? It's line 865.
Yeah.
Yeah. So basically here you can see that the question involves something about math, but why would you send this to Wolfram Alpha, right? Because Wolfram Alpha would just not be able to solve this problem. But the model being able to have, it was trained with all this knowledge internally, you can just basically use the model itself to retrieve the answer. So it will just try to give you an answer based on what is seen during the training, which is something that you would want in this case, let's say. So the idea is very simple. You have examples. This is the few shots. This will try to learn all of this. Then you have the toolbox. Based on the toolbox, we do the branching. So you might want to search something. You might want to use a crawler, a text-to-image, OCR, and so on and so forth. And we also, something important for us was to make the model say, I don't know something. And this was inspired by a paper that was called Crawling the Internals of Large Language Models. They were doing experiments with this I don't know idea. And I would like to, I mean, we would like to know when the model doesn't know what's the user is talking about, right? So that you can process that itself. You can also see that there is a recall in there. And the recall functionality basically will create a double branching. So if you classify the user query as a recall, think about it. You might ask Symbia, did we ever discuss about my appointment to the doctor? Right? This is like clearly a recall question. So what you would like in this specific case is to enter in the branch of recall. And then, Marius, if you can search for the memory capabilities, which would be a little bit down. Because that's exactly, just go a little bit to the examples here. A little bit down, yeah. No. Line 920.
Sorry.
Yeah.
Sorry.
So if it enters the branching of the recall, then you have another branching which basically try to look if it's a duplicate, right? If this information already exists in your long-term memory, don't save it. The information might be irrelevant because it's some follow-up question, like the user might ask, what do you mean? And that you don't want to save that. Or you can actually want to save the information. So you can look at this scratchpad format, which is basically how we pass this second time into the large language models to create this notion of memory. So this will just get filled. Think about them as shorter memory. It will just get filled by the sliding window. Long-term memory, it will just get filled as it retrieves from the database. And we also have this reflect component, which is super important. The reflect, as you have seen in the paper, reflects and so on. There were papers that came out about this. We always try to make Symbia think between codes, right? So like having its own internal representation of what the user wants. So if the user is asking something, did we ever discuss an appointment? Then Symbia internally will try to have this like self-thought in which it asks, okay, the user was trying to ask me about if there was an appointment. I would probably have to recall this from my memory. So it's trying to use this this idea of having thoughts, because if you have these thoughts, then you can do much more interesting things. And Marius and I are working on this. We try to do like the chain of thought, the tree of thought paper, which came from DeepMind. And yeah, there are a lot of strategies that you can do with thoughts. If your chatbot / agent has thoughts, you can use those thoughts to make more clever decisions if you want.
I might like to add, I really like this idea of using memory to condition the prompt generation, because indeed we learn a lot through basing our decisions on the memory we have in the past. So like stuff like short-term, long-term memory, and even this reflection is actually something that is quite inbuilt in humans as well. Like we tend to reflect about what's going on in the world, and from there we can make more meaningful decisions. You can treat this reflection as some form of intermediate state whereby you go closer to solving a problem by like going one step away from the input, because usually the input can be quite convoluted. You can take one step to reflect and say, oh, what does the user actually want, or what should I be actually doing if I see this kind of input? Yeah, so this is really something that is something that should be investigated more. And you can see the beauty of this Symbia or this tool framework is that you can actually add in your own tools. Or in this case, I would say that these are more like actions also, because each action can actually use the same tool, but use it in a different way. And you can just represent the action in these square brackets and give some examples. Like you can do the 0-shot example at the start to describe what it does. And you can do a few short examples by showing an example of how Symbia should interact. So I really like this framework a lot. Yeah.
Thank you. Yeah, and this is basically, I'll take over again. This is basically how we do this detect capabilities, what you saw here at the bottom. So you could obviously implement your just, subclass, the chatbot, during the init, just put in your own capabilities, and then you're good to go, as you just said, with your own in-context classification and so on. So after we kind of like detected or asked a few questions back and forth, we basically now have some context, or if, something is like, you expect that there is some input. If it's not, then you don't know what the user is talking about anyways. But after we detected that, we can just do simple now checking, because that's why we also cast this object. Now we would get another symbol out of it, but now we're just casting it to a string, because why should we pass everything to the backend, to the LLM? Because if we wouldn't do the stringifying here, basically, then we're basically doing the in contains statement, asking the LLM if this is contained. You could do that, but I wouldn't do it for so trivial requests. So that's why we just go to a string, and then it's just much faster. And then we're just checking. And this is basically just this branching that we saw. So we have this cascade of just exiting, help, recall, or don't know. Or if it's something else, then it's probably one of these tools that we saw before. And there is obviously the symbolic search engine, crawlers, and other things that you can look at. And then we're just basically narrating. This is maybe one of the things that is interesting. So as soon as we did something, let's say we, I don't know, searched on the internet, for instance. So what we're doing actually here is there's a few more steps. So we're getting the user symbol. We still have that object, right? Then we're doing extraction. This extract is basically trying to extract in a more meaningful way the user content. So you might type an entire sentence, but then in the end, like in a search engine, you wouldn't throw in this sentence, right? So what we're doing here, we're just extracting the Google query, if you want so, and then we're passing on this Google query to the search engine. Then you get the response. And what we're then doing is basically we're instructing Symbia to behave in a certain way, because actually what's happening with Symbia is it's not a two-way conversation. It's not user conversing with Symbia. Actually, it's a three-way conversation here happening, where we have the user, where we have Symbia, but then we also have the narrator. So the narrator is always before Symbia, which is kind of instructing Symbia how to answer back. So these are probably also how I think Project Sydney and Microsoft also, or OpenAI showed how they kind of steer the model to behave in a certain way.
Sorry, so if I may add over here, this narrate reminds me of this React framework, whereby the observation from your environment can be used to condition the agent. Because right now, if you don't give this narration, the AI agent doesn't know what takes place externally. Like in this case, do online search, or like, for example, you have replied to the user with the solution of the math problem. The AI or Symbia doesn't know that this is happening, because from the point of view of Symbia, only the user has typed something. So this narration is to close the loop from the environment or the tool usage back to like the large language model. So is that right?
Exactly. Yeah, exactly. It happens multiple things. One of them is to instruct the model how to reply, because maybe you want a nicer answer, not just 13 or so, right? If that's what comes out of the computation. So you want like, yeah, today it's 13 degrees Celsius or whatever, and something like that. The second part is interacting with the memory, as you just said, exactly, because what's happening is actually you had this one interaction, you did a lot of computation and extraction, but now Symbia would have no idea what just happened, right? So by giving it this basically information now with the context from the response and what to do, it can, if you would look into the narrate function now here, then we see that basically there is also this category of the recall, but there is also like how to save the information, right? So this is actually what also Leo talked before, about the duplicates, if it's irrelevant or if it's like necessary to save the new information, because maybe we talked about some elaborate, conversation and so on, and now we want to store that information for long-term memory and retrieve it later, about the appointment of the doctor or whatever. Yeah.
So that's interesting. Not all information is stored in long-term memory, right? Only those that
Exactly
need to be relevant.
Yes,
Yeah.
Exactly. Because it could be just, you could have some so just some facts, like why should you memorize x squared plus 1 or whatever, because you can look it up every time, right? Or why should you memorize, I don't know, if it just says, I don't understand your request, what do you want from me, in a way, or whatever. Why should it memorize that it doesn't know what to reply to the user, because it's just stateless, right? In this case.
You got me interested here. Yeah. Oh, sorry, Leo, you can go first.
So I just wanted to add something. So one important thing here is to keep into account the capabilities of the models, because if you're doing this kind of chatbot with something like ChatGPT, it might not perform in context classification as well as GPT-4. So I hope that goes without saying that they are very different models and one is more capable than the other. And the second thing is that you can always explicitly tell to the model that you want to store something. Like, for example, you actually discuss something with the model, probably you liked its reply or something like this, or you can just specifically tell, please save this to the, please store this, or please, you don't have to say long-term memory or something like that. You can just, please store this so that you can later recall or something like this. Then it will save that information in the long term, because that's the way we do the branching. So you can be explicit in what you want to store, but it does this even by itself in the background, right? So it was both ways. At least it should, based on the in-context classification.
Yes. Exactly. I mean, all of these things are probabilistic, and this is exactly what our framework also introduces, is like this notion of not just having this classical world and having, where everything is nicely defined but doesn't generalize, or having everything probabilistically, right? Just everything is one shot or a few shots or whatever. So the idea is to work between both realms. Obviously, what we get out of it is a probabilistic programming language or environment, if you want so. So some things can go very well if the model is really good, or if it's like poorly or has underrepresented data in some regions, then obviously it can go wrong. To always keep that in mind as an expectation, that's important. But I think it's still like really, really powerful tooling to see how we can now combine just both worlds and then merge them together in like a really simple way to code, right? Because the idea is not to have like a lot of meta code around it and a lot of statements. It's just like one statement, like in or whatever, or a query or something like that. It's more becomes more like integrated with the language, right?
Yeah, because if you're doing like the way we're doing in here, it's, as you said, it's not the in that we overload in the symbol, because it doesn't have to be, because the in context should only return you the don't know or exit or help or something like this, right? So it's not a need to perform the more the large language model driven in statement.
Exactly. Yeah, and that's about it for today, I would say. Next time we can talk about package managing and how people maybe can create their own components and how we can bring all these things together, and look at interface and other stuff. But I would say for today, I think that was a lot to take in anyways.
Yeah, quite interested to help or to develop more on the memory part. Like we could also put in like when what kind of memories are more important to retrieve, what kind of memories are more important to encode. Also, like maybe some form of emotion can be encoded in through some form of classification, because that's also how we remember. Remember the more impactful memories more, and that kind of biases the decision. So something like that maybe can be incorporated. And I mean, that is future work. I can discuss more of you as well, because you got me intrigued. I'm actually very interested in encoding memory stuff. Just want to check also, like for this chatbot, all right, if let's say I want to run it, okay, and will I be able to see back end, like what's happening to like the narrator, to the like basically all the stuff that the AI is seeing? Because right now, so far what we have seen so far is only the output to the user. Is there a way to show the intermediate steps? Because I think people might be interested to know what's going on behind the hood.
Yeah, that's exactly what this trace is all about. So basically, this trace, when you activate it, you can activate it on all engines and so on. But when you activate this, that's what you get, like is stepwise logging. It's basically you have this call stack, if you want, so of functionalities that are triggered. And this is in this case the call stack of using just the one query function here. But if you would have a stream of expressions, let's say we would have something like a sequence, and then we start, I don't know, maybe I think compose, and then no, the other way around, maybe makes more sense. First we query something, and then we compose I don't know, text out of it.
Compose a poem or something. Compose a text, yeah.
Yeah, exactly. So yeah, what was it?
You can also run this trace wrap around the chat function, right? So you can see what's happening behind the scenes of Symbia.
Yeah, should actually work. Yeah, exactly. That's the whole point, because it's similarly implemented to also when we exit the chatbot, for instance. You would get if the models are supported, because there are some models are supported. We have also this same statement just with the cost tracker, so you can basically look at what was the breakdown. In this case, this model is not supported, but anyhow, you would just get a summary of all the tokens that have been streamlined over the model, and we will add more and more.
You can see that at least it tracked the zero shot and the few shot that you perform, so you can see at least how many times it's no zero shot in this case.
Exactly. So in this case, this was what was sent to the model. The background, in the same way, also the trace works with the Symbia. So if we do, I don't know, tracing your symbolic engine, and then say sim.
Yeah, no worries. Yeah. So I think if we want to do the detailed interaction behind the hood, the trace function is all that you need to do. You can just wrap around the chat function, I believe, and that should be, yeah. So you can see like what's going on. Can we even see the messages that are going on?
Yes.
Yeah. There's some, I don't know, some error throughout, but anyhow, the narration.
Yeah, no worries, because
could you provide more information, something like that? Because I asked it basically.
Oh, you see on the right there, that's exactly what we need to know, like, oh, what happens behind the scenes. Symbia chose hello there, then it was retrieval and so on. Yeah, so I think that's really, like, if you want to do your own tool engine, all right, and you want to implement various tools and see what tools are being selected, this should be able to tell you exactly what's going on under the hood, and then you can go and configure it. So I really am quite excited about this, because it is really quite dynamic. I think it's even more versatile than OpenAI functions or the plugins, because those don't really interface with memory, and it doesn't do this whole systems level integration. This is more native. You can just configure the whole the chat class, and then this Symbia chat, you can override it, and then you can configure your own functions as well, your own functions, your own tools that you can use. Yeah, I would even say that it's more versatile than LangChain agents, because LangChain agents is a fixed format. You can actually do your own format here. So yeah, any final words before we end today?
Yeah, I mean, there are many things, that we still have to code, support, for develop. So if anyone wants to try it out, has some, issues, whatever, just report them. Maybe you can even, try something out, debug it. we're always grateful for any help and for any support, or at least a
Or
star or something.
any ideas
Sure,
or
exactly.
features, or
Yeah, that would be cool,
would be
because then we
like
can
super
extend that.
cool. Yeah.
Yeah, I'll definitely work
So
with you all more for the memory part. I have some ideas based on what I see in your framework. So I think this whole part of integrated systems with an action. I know you don't like the word agent, but let's say an action tool master able to like interact with tools and then like use its past memory of tools to choose the tools again. Something like, you know, Voyager, you can choose tools better iteratively. I think all this can be implemented here. Yeah, with just the right
Yeah,
kind
sure.
of ways to override, like to override the function. Yes.
So the idea is that the way to think about it is like you have, this is at least the way I think about it. Like you have this pieces of puzzles, but they don't. It's like you have pieces of puzzle, but you can put them and arrange them in many different ways, and you always create like a different big jigsaw if you want. So the final puzzle that when you solve it in a way, is like it will always show a different image, but the components atomically, at least in the symbol and expression and all the things that we implemented right now, they are there. So the way you use them, it's up to you. You can always like define a different puzzle if you want. You can always solve it something differently with the same pieces.
Yeah, I can easily see you can even do expert chatbots, like each of them doing a specific function and all interacting with one another. All this should be possible. You just need to have different implementations of the chat with different.
Actually, we had this idea to we have we also have some research ideas in which, for example, you can ask the question, can a conversation reach an equilibrium, right? What would happen if two agents converge to the same thing, right? And you can think about this idea or this question in terms of game theory. And if you think in terms of game theory, you have tools in game theory that would allow you to perform like Nash equilibrium to check if the or you can even create like games, right? You can try to solve like the dilemmas that there are in game theory with this kind of agents. Yeah.
And the idea is especially what we're thinking about and how to also evaluate that, because it's about, think of it this way: if you want to generate stuff, like let's say it's the full idea of the framework or the vision is where we want to go with this is that it's like a meta programming platform. That's what LLMs and the classical realm are kind of like bringing together, right? So you can now have this stream of functionalities and compose them together and so on. But the problem is when you generate them, the longer the components and everything gets, right, the more probabilistic it becomes. And the point is, how do we get to, let's say, some stable result? Because if you run the same code twice or 3 times or more, you want to obviously get similar results at least, right? Semantically speaking.
Semantically, yeah.
And these are challenges that we're looking at right now. We're developing, we're building code around it. And we're happy for any, support or ideas from the community.
All right, it's been a long video already, and I really thank you for showing us how this SymChat works and how the tool interfacing is done. In fact, even the streaming option with the document loader is already good enough for a lot of use cases like memory retrieval, document QA. Yeah. So I think
we thank you. We thank you for taking your time to chat with us.
Yeah, thanks. And if anyone would like to contribute any ideas to the SymbolicAI framework, to this tool maker and like SymChat or any other thing, feel free to let us know. And yeah, I look forward to implementing more stuff about memory onto it. All right.
Yeah, and please start the repo. Yes, we need more stars. Never forget to start the repo. That's the quickest kind of support that you can do. Just start the repo.
Thank you.
Okay, thanks everyone, and bye.
Bye.